Hello guys, my name is Akash and today we are learning about a basic concept that is magnetics. The introduction of magnetics, magnetic circuit, magnetic materials and their properties, magnetically induced EMF and force, AC operation of magnetic circuit and hysteresis and eddy current losses. Introduction. An electrical machine is a device which converts electrical power into mechanical power and vice versa. A motor describes a machine which converts electrical power to mechanical power, and a generator or alternator converts mechanical power to electrical power. Almost all electrical motors and generators convert energy from one form to another through the action of a magnetic field. By using magnetic field, we convert the power from electrical to mechanical. Transformers are usually studied together with generators and motors because they operate on the same principle, but the just difference is the action of a magnetic field to accomplish the change in voltage level. Principle of electromagnetism. The principles of electromagnetism plays an important role in the operation of an electric machine. The basic idea behind an electromagnet is a magnetic field around a conductor can be produced when current flow through a conductor. In other words, the magnetic field only exists when electric current is flowing. By using simple principle, you can create all sorts of things, including motors, solenoids, read oblique write head for hard disks and tape drives, speakers, and so on. What is magnetic field? Magnetic field encircle the current source. Field is perpendicular to the wire and the field direction depends on which direction the current is flowing in the wire. A circular magnetic field developed around the wire follows a right hand rule. Properties of magnetic lines of force. Magnetic lines of force are directed from north to south outside the magnet. Magnetic lines of force are continuous. Magnetic lines of force in the same direction tend to repel each other. Magnetic lines of force tend to be as short as possible. Magnetic lines of force occupy three-dimensional space extending theoretically to infinity. It leaves a magnetic surface at right angle. Magnetic lines of force cannot cross each other. Examples of electromagnets are: an electromagnet can be made by winding the conductor into a coil and applying a DC voltage. The lines of flux formed by current flow through the conductor combine to produce a larger and a stronger magnetic field. The center of the coil is known as the core. In this simple electromagnet, the core is air. Iron is better conductor of flux than air. The air core of an electromagnet can be replaced by a piece of soft iron. When a piece of soft iron is placed in the center of the coil, more lines of the flux can be flow and the magnetic field is strength. Basic of magnetic circuit. Magnetic flux. It is denoted by phi. The magnetic lines of force produced by a magnet is called as magnetic flux. Its unit is Weber. 1 Weber is equal to 10 to the power 8 line of force. Flux density. It is denoted by B. The total number of lines of force per square meter of the cross-sectional area of the magnetic core is called as flux density. Its SI unit is Tesla or Weber per meter square. Magnetomotive force. The amount of flux density set up in the core is dependent upon 5 factors: the current, number of turns, material of magnetic core, length of core, and the cross-sectional area of the core. More current and more turns of the wire we use, the greater will be the magnetizing effect. The ability of a coil to produce magnetic flux is called as magnetomotive force. MMF is equal to number of turns into current in ampere. Where MMF is the magnetomotive force in ampere turns and N is the number of turns. Magnetic field intensity. It is denoted by H. The magnetic field intensity is the MMF per unit length along the path of the magnetic flux. It is also known as magnetic flux intensity. Its unit is in ampere turns per meter. Magnetic flux linkage. It is denoted by lambda. The product of magnetic coupling to a conductor or the flux through a single turn times the number of turns in coil. Lambda is equal to N phi, which also relates to define inductance as lambda is equal to Li, where L is inductance. Reluctance, it is denoted by S. It is the opposition of a magnetic circuit to setting up of a magnetic flux in it. Flux is equal to phi is equal to B into A, where F is equal to MMF is equal to HL and B is equal to mu H, where S is the reluctance of the magnetic circuit, L is the length of magnetic path in meters, mu naught is permeability of free phase, and mu R is the relative permeability. What is permeability or mu? It is a property of a magnetic material which indicates the ability of magnetic circuit to carry electromagnetic flux. Ratio of flux density to the magnetizing force, that is mu is equal to B by H. Its unit is Henry per meter. Permeability of a free space or air or non-magnetic material is mu naught. Mu naught is equal to 4 pi into 10 to the power minus 7 H by M, where relative permeability or mu R is equal to permeability upon permeability of a free space or air. What is residual magnetism? It is a magnetism which remains in the material when the effective magnetizing force has been reduced to zero. What is magnetic saturation? The limit beyond which the strength of magnet cannot be increased, called as magnetic saturation. Thank you, friends. After watching this video, please subscribe to my channel. Thank you.